Hey there, Math Rock Stars. We are looking at transformations and combinations in this video, and we're going to do a little practice of describing how some parent graphs were transformed and doing a little sketching. So a lot of the time, you're not going to just see one transformation, you're going to see a bunch of transformations happening all in the same problem. And when sketching a function that involves multiple transformations, it's important to know, well, which one do you do first? So there's an order of operations, just like with PEMDAS for arithmetic, there's an order of operations for transformations. And this is it. Horizontal shifts, and then stretches and compressions, then reflect about the y-axis, reflect about the x-axis, and then vertical shifts. Now it's okay to take these three here, the stretches, the reflections, about the x and the y-axis, and put them in different orders. Like, totally okay to do that, but really important to always start with the horizontal shifts first. And then whatever you're doing in the middle is fine, but then finish with any vertical shifts that you want to do. So horizontal shifts are first, vertical shifts are last. And those are the ones you really have to pay attention to. The other ones should be okay. Don't worry too much about transformation order of operation. In this course, it doesn't make a big appearance. It will show up often though in pre-calculus. So it's just good to have it there in your bag of tricks. Let's jump in and do some sketching. So instructions say sketch each of these absolute value functions, describe how the parent graph was transformed, and we're going to start off with the parent function f of x equals the absolute value of x. So for all of these, we're starting off with our parent function, our famous v, centered at the origin and opening up. Okay, in our first problem, it looks like we're adding 3, which means that we have a vertical shift. We're shifting up 3. Shift up 3. So the graph is going to look like this. 1, 2, 3. Same familiar v, just move it up 3 units. In the next one, we're subtracting on the inside the absolute value bars. We're subtracting 2 from the x. So this is also a shift, but this is going to be a horizontal shift. And because it's a horizontal shift, it's kind of opposite of what our intuition thinks, instead of it being left, like we would think it'd be left. We're subtracting. It is not. It's going to be a horizontal shift. So another shift, but it is to the right 2 units. So we're going to move our vertex over 1, 2. 2 places to the right. And there's our transformed absolute value graph. Next one has 2. There are 2 transformations that are happening here. We've got a reflection, because I've got a negative outside the function, and we've got a shift, because I'm adding 1 inside the function. So the outside of the function, that negation means a reflection. So I'm going to reflect over the x-axis. This is a vertical shift, or sorry, a vertical reflection. And inside I have a shift. It's a horizontal shift. So this is going to be a shift to the left, 1. Now I know I need to perform any horizontal shifts first. So I'm going to move my v to the left 1 first. So my vertex is going to move over 1. And then I can do whatever other transformations are happening. I'm supposed to reflect over the x-axis. So it's going to be an upside down v. Here's another one with 2 transformations. They're both inside the absolute value bars. They're both happening to the x. So when I'm negating the x, that means I'm going to reflect over the y-axis. And when I'm multiplying by a number that's bigger than 1, that's going to correspond to a horizontal shrink or compression. So that means that I'm going to have my V flipped over the y-axis, and that's not going to look any different than if I didn't reflect it. Remember that symmetry around the y-axis. But the horizontal compression is going to make a difference. When I compress things horizontally, I'm moving my x-axis in. And when I do that, it's going to make my V close up. Next transformation, 2 again. I've got a number that I'm multiplying the entire function by. This is on the outside, so this will be another compression, but this is going to be a vertical compression this time. Remember, if I'm multiplying by a value that's between 0 and 1, that means it's a vertical compression. If I'm multiplying by a number greater than 1 outside the function, that's going to be a vertical stretch. And then I'm adding 1 on the outside. Adding 1 to the function is a vertical shift. So vertical shift is going to go up 1. All right. What do I do with vertical shifts? Vertical shifts are last. So I'm going to move that graph up 1 when I am done. Eventually it's going to end up here. The vertical compression means that the V is going to open up. So it's going to start at 1, but it's going to be far more open than my parent function. And our last example has 3 transformations. Oh, no, 4 transformations. I've got a negation of the entire function. So negation on the outside, that is a reflection over the x-axis. I've got a number that I'm multiplying on the outside, so that number is bigger than 1, which means it's a vertical stretch. Also on the outside, I'm subtracting 5, so that will be a vertical shift down 5 units. And on the inside, I've got a horizontal shift. It's going to be a shift to the right 3. So I have horizontal and vertical shifts. I better check to see what order to do them in. Horizontal is first, vertical is last, and everything else can happen as I want to in between. So let's shift horizontally to the right 3 first. 1, 2, 3. All right, so we're starting here. I have to reflect my equation over my graph over the x-axis, and it's going to be vertically stretched, which means it's going to be skinnier. So it's going to look like a skinny V. And then it needs to shift down 5. So my final graph, 1, 2, 3, 4, 5. 2, 3, 4, 5 is going to start down here at 3, -5. Be a skinny opening V. In the next video, we'll do a little bit of going in the other direction. So we'll start off with an equation, or start off with a graph and come up with an equation.